Welcome to Propeller Breeze, the show for student pilots, sim fans, and everyone chasing that first solo and beyond. All information in this podcast is for entertainment and general knowledge only. Always verify with certified flight instructors or regulatory authorities before attempting anything mentioned here.
Welcome to the deep dive.
Good to be back.
So today we're really focusing on a specific audience, the student pilot.
Yep. Anyone working on their private pilot license?
Exactly. If you're in that boat, you're probably spending a lot of time looking at a glass cockpit.
Oh, absolutely. The old steam gauges are becoming rarer and rarer in training fleets.
So for this deep dive, we're going to look at how that big transition to modern screens, well, how it really changes the whole game of monitoring your aircraft.
That's it. We're focusing on electronic flight displays, or EFDs. And they aren't just, fancy TVs in the cockpit. It's a completely new way of delivering information.
We've gone through a lot of training documents, some manufacturer notes, and our mission today is pretty simple. We want to unpack the primary flight display, the PFD.
Which is the screen that basically replaces that traditional six-pack of instruments you'd see in an older plane.
Right. And when we say EFDs, it's really two main components, isn't it?
It is. You have the PFD, where all your core flight info lives, your speed, your altitude, attitude, and then you have the MFD, the multifunction display.
And that's for navigation, engine data, all the other systems.
Exactly. And the sources we looked at, they all point to two huge benefits here. First, a massive improvement in system reliability.
Which leads directly to safety.
Directly. And second, and this is the one that might sound a bit strange at first, is a decrease in the overall cost of the equipment.
Okay, wait, I have to stop you there. That seems completely backward.
Yeah.
How are these complex, high-def LCD screens cheaper and more reliable than 6 simple mechanical gauges?
It's all about integration versus complexity. A single analog gauge might seem simple, but it's full of delicate moving parts.
Gears, diaphragms, all that.
All of it. And they're all susceptible to wear, to vibration, even tiny leaks. The PFD systems, on the other hand, they rely on centralized solid-state computers.
The ADC and the AHRS.
The ADC and AHRS, they send a digital signal. There are literally no moving parts in the display itself that can fail.
So the failure point isn't 6 different moving things. It's maybe 1 or 2 really rugged computer units.
Precisely. And the cost goes down because once you have the platform, the screens, and the computers, you can configure it for a totally different airplane just by loading new software.
Instead of ripping out the panel and installing all new physical gauges.
I got it. It's a huge shift.
That makes a lot more sense.
Okay.
Let's jump into the PFD itself. I mean, the change to the cockpit design is just, it's dramatic.
It really is. Designers used to have to cram 6 different round gauges into a small space. It was always a compromise.
And now all that critical information is just pulled together onto one LCD screen.
Which, yes, it reduces clutter, but the real benefit is cognitive. It changes how you scan.
Yeah.
Instead of your eyes darting all over the panel, you have this one integrated high-density picture of what the airplane is doing.
That should, in theory, help you understand the aircraft's state much faster.
That's the goal.
So let's break down that view. The PFD is home to 5 of the 6-pack instruments. We've got airspeed, attitude, altimeter, VSI, and heading.
We'll get to the tachometer, the 6th one, a bit later. It's the exception.
Okay. So let's start on the left side of the screen. The airspeed indicator, which is now an airspeed tape.
A vertical tape, yeah. And this is a big change for new pilots. As your speed goes up, the bigger numbers actually scroll down.
Right, past a little fixed reference line in the middle. But what strikes me is just how much more information is packed in there compared to an old dial.
And that's the power of digital. It's not just your current speed, it's context. You have your V speeds, VX, VY, VR marked right there on the tape for you.
So for a student pilot, you don't have to memorize those numbers for your specific training plane. They're just there.
They're right there. And the color coding is still there, too. The green, yellow, and white arcs for your normal caution and flap ranges.
But the digital warning system is so much more immediate.
Oh, it's unmistakable. If you exceed VNE, that never exceeds speed, the number value of your airspeed doesn't just point to a red line. It flashes, and the number itself turns a bold red.
You can't miss it.
You cannot. And there's one other piece of data there at the bottom of the tape. True airspeed, or TAS.
Which is something analog gauges just couldn't do in real time.
Right. To get that, the air data computer, the ADC, is taking your indicated airspeed and combining it with data from the outside air temp probe and barometric pressure. It's a constant live calculation.
Okay, moving to the center of the screen. The attitude indicator. This is probably the biggest visual upgrade.
I'd agree with that. The digital artificial horizon spans the entire width of the PFD.
Unlike the old, small 3-inch gyro.
Exactly. And when you're in a turn, or God forbid, recovering from an unusual attitude, having that massive, full-width horizon line is a huge boost for your situational awareness. It gives you a much better feel for your bank and pitch.
And the data for this is coming from the AHRS, right?
Correct. The attitude heading and reference system. Think of it as the modern solid-state replacement for the old spinning mechanical gyros. It's way more reliable and doesn't have problems like tumbling.
A very real problem with the old ones. Okay, shifting to the right side of the screen, we've got the altimeter.
Another vertical tape. And just like the airspeed tape, as your altitude goes up, the numbers scroll down.
And your current altitude is always shown right in the middle, in a black box.
And this is a key detail for precision flying. That readout in the box is in 20-foot increments. That level of clarity is vital, especially when you move on to instrument flying.
And you've also got the current barometric pressure setting right there, so you can dial in the new AHRS report easily.
Yep, it's the digital Colesman window.
Right next to that, we have the vertical speed indicator, or VSI.
This is your rate of climb or descent. It can look like a little arc or sometimes another small vertical tape. And crucially, it has a vertical speed bug.
So you can set it to, say, a 500 foot per minute descent in the pattern.
And then just fly the plane to match the bug. It makes holding a steady rate much, much easier, especially when you learn how to use the trend vectors we'll talk about.
Okay, that's the core flight dynamics. Let's look below the horizon line now at navigation and coordination. We've got the heading indicator,
which is usually modeled to look like a classic HSI, a horizontal situation indicator.
And this is the AHRS working with another component, the magnetometer.
Right. The magnetometer is basically a highly accurate digital compass. It senses the Earth's magnetic field, sends that data to the AHRS, which then stabilizes it and puts it on your screen as the HSI.
Okay, now for coordination. This is where the old ball in the turn and slip indicator gets a digital makeover. And I know this trips people up.
It does, because it's represented by a couple of different things. First, you have your slip skid indicator.
That's the little horizontal bar right under the roll pointer, the triangle at the top of the attitude indicator.
That's the one. That bar is your new ball. It tells you if you're in a coordinated turn.
So how do you read it? If the ball was halfway out, what does the bar do?
The rule of thumb is pretty simple. If that digital bar is one full bar width off-center, that's the same as one ball width displacement on the old gauge.
Now step on the bar, just like you'd step on the ball.
Step on the bar. You need rudder in the direction the bar is deflected, and that data comes from accelerometers inside the AHRS unit.
Okay, so that's coordination. But then there's the turn rate indicator, which is about performance.
And that's in a different spot. It's usually found just above the rotating compass card. You'll see some little tick marks.
For standard rate and half standard rate turns.
Exactly. When you roll into a bank, you'll see a magenta trend line move. If that line extends out to the second tick mark, you are in a perfect standard rate turn. 2 minutes for a 360. It's incredibly precise.
That distinction is so important. The bar is for coordination. The trend line is for turn performance.
You've got to practice telling them apart. Now, that covers 5 of the 6.
Yeah.
We have to address the exception.
The tachometer. Engine RPM.
Right. It is the only one of the traditional 6-pack that is not normally on the PFD.
So where does it live?
It's typically on the MFD, the other screen, along with all your other engine data, fuel flow, oil pressure, temps.
But what if that screen fails?
That's where the built-in redundancy is so brilliant. If the MFD goes dark, the essential engine instruments, including the tach, automatically show up on the PFD.
So you're never without your critical engine data.
The system makes sure of it. It's a key safety feature.
Okay, let's go behind the screens now. Let's talk about the brains of the operation, starting with that air data computer, the ADC.
The ADC is, think of it as the aircraft's super smart digital barometer and thermometer all rolled into one. It takes in all the raw pitot and static air pressure.
But instead of that pressure physically moving a needle in a gauge,
it just sends the pressure data to the ADC.
Yep.
The computer then instantly calculates the difference between total pressure and static pressure, and boom, that's your airspeed. It's all digital computation.
And it computes altitude differently too, right?
Totally different. There's no physical diaphragm expanding. The ADC just measures the static barometric pressure electronically, compares it to the setting you've dialed in, and sends a precise digital signal to the PFD to display your altitude.
And it does it so fast that you get rid of a lot of the lag you'd see in a mechanical VSI, for instance.
Exactly. And from a maintenance perspective, the ADC is a separate solid-state box.
A line replaceable unit.
So if you're getting bad airspeed data, you don't troubleshoot 6 different gauges. You can just swap out the ADC box in minutes. It makes maintenance so much faster. And that ADC is feeding data not just to your screen, but to the autopilot too.
This digital processing power is what leads to what I think is the real aha moment of glass cockpits, the thing that really changes how you fly.
You're talking about trend vectors.
Trend vectors.
They are absolutely essential. For the student pilot listening, these are the little magenta lines you'll see extending from your current speed and your current altitude.
What are they showing us exactly?
They're showing you a projection. The ADC is constantly calculating your rate of change, how fast your speed or altitude is changing, and it displays a 6-second projection of where you're going to be.
6 seconds into the future. That's a huge deal. How does that change how a pilot actually flies?
It changes everything about your control inputs. Let's say you're climbing to 3,000 feet. Instead of watching the altimeter tape scroll and then reacting when you hit 3,000.
And probably overshooting it a little bit.
You always do at first. With the trend vector, you can see that magenta line shooting up towards 3,000. So you start to gently lower the nose before you get there. You use the vector to anticipate.
So you're leading the aircraft instead of chasing it.
You are flying 6 seconds ahead of the aircraft. When you're on final approach trying to nail your airspeed, that little magenta line on the speed tape tells you instantly if you're starting to decay. You can add a touch of power before the actual number even changes. It allows for incredibly smooth, precise control.
That level of customization and just the flexibility of being able to update the software, it's something you could never dream of with analog systems.
Not at all. A manufacturer can use the same screen hardware in a dozen different planes just by loading a different software package. That standardization is why EFDs took over the industry so fast.
Okay, let's try to wrap this up. For the student pilot listening right now, what's the big summary here?
Well, we've seen that this shift to glass cockpits gives you a huge boost in safety through reliability and redundancy. It clears up the panel by pulling all that data together.
The PFD is basically one integrated flight system with all the data being crunched by the ADC and the AHRS.
Right. The ADC handles your air data speed, altitude, and the AHRS handles your orientation, your attitude, and heading.
And together they create this incredibly rich picture of what the plane is doing.
Exactly. So here's the final thought, the challenge for you, the student pilot. These systems, they've given you predictive tools, things like trend vectors that your instructor, when they were learning, probably never had.
They learned to fly by chasing the needle.
They did. So the question to think about is this. How does learning to fly with a 6-second projection into the future? How does that change the fundamental rhythm of how you make your control inputs? How you adjust pitch and power?
It's a totally different way of thinking. You're not just reading the instruments, you're reading the future that the instruments are showing you.
That's it. So our recommendation is to really dig into the specific training materials for the avionics in your aircraft. If it's a G1000, find the G1000 Pilot's Guide. Master what those trend vectors are telling you. It will make you a much more precise pilot.
That's it for this episode. Keep your wings level, your brain sharp, and catch you next time in the pattern. Thanks for riding with Propeller Breeze.